Hello and welcome. I'm now going to show you the easiest way to do Pythagorean theorem. Okay, this will be the toolbox that we use when we're going to deal with a Pythagoras. We're gonna learn how to transpose and also how to deal with square and square roots. Okay, so when you're transposing, you're actually dealing with two things: variables and numbers. So variables is just a mathematical term, but actually it refers to alphabets. So each and every alphabet that you find in mathematics is called a variable. So now what that means is that you must keep numbers on one side of the equal sign and the variables on one side of the equal sign. If you have something like this, okay, sorry, this is a number. So what happens here is that you must keep numbers on one side of the equal sign. So in order to do that process is called transposing. We're going to move 3 to this side of the equal sign. So this side will be left with y equals to 2, and this is our 3. So now another thing, because 3 has moved from this side, you see our 3 was a positive. Now when it moves to that side, it becomes a negative. Then when you solve this, your y would become -1. Okay, another example, you'd have your r plus 7 is equal to 2. Okay, in this case you'll also have your 7 must come this side to join the other numbers, and you'll be left with your r here, which you have 2, and you have your 7. Then since it was positive, then it becomes negative. Then your r is equal to -5. Okay, let me give the last example. Okay, I'm going to give the last 2 examples of transposing. Now I'm using the alphabet R, X, and Y, which is normally what we find in our Pythagoras theorem, but you can actually use any other variable or alphabet. Okay, so now let's look at this one. I have 5 equals to 2 plus y. So since I said variables, remember, is variables versus numbers. So it means that numbers must be on one side of the equal sign, then variables on one side of the equal sign. So in this case, I'll be moving 2 to this side. So which means I'll be left with y this side. This side I have my 5, then I'm moving my 2 this side. So what happens to my 2 is that it was positive, it becomes -2. Therefore this will be a plus. Therefore it's -2 plus 5. That gives my y, that makes my y equals to 3. Another way you can do this is saying, so I'm left with my y here. So I had 5 here, so I'm transposing my 2, it becomes 5 minus 2. Then my y would become a 3. Okay, the last example then would be a 7 equals to x plus 4. Now it means I have to move the 4 this side. Okay, so it means if I move 4 from this side, I'm left with x here. Then this side I had a 7. Then when I move, then here's my 4, I've moved it. Then since I've moved it, it was a positive, now it becomes a negative. Then I'll have my x equals to 3 there. Therefore that's how transposing is done. Then the next part will be how to remove the square. Okay, now removing a square on a variable, which is the next part that you need to know in order to solve Pythagoras theorem. Okay, in this case it's actually squares and square roots. In order to deal with a square, you need a square root. In order to deal with a cube, you need a cube root. But in this case, we'll only speak about a square. In this case, you'll have your r squared equals to 16. In order to remove your square, you must square both sides. Then this square root will cancel the square. You'd be left with your r. Then you'd need the square root of a 16, which is 4. So you'll notice what we do is, when I put a square this side, I'm also putting this side. And in doing so, I'm actually solving the equation. Now, in this case, you have 25 equals to y squared. So in this case, you'd also use square roots on both sides. So if I square both sides, in this case, I'm using the square root in order to cancel the square. So which means I'll be left with y here. Then in this case, the square root of 25 would be a 5. Okay, and the last part would be 64 equals to x squared. Okay, now in this case, the 64 equals to x squared. Remember, actually I'm supposed to start with the side that I want to cancel the square, the side where there is a square. You understand? Okay, now in this case, I'll square this side, I'll also square this side, and I'll have my x. Then this would be an 8, I think. Okay, then that's how we remove the squares. Okay, now we actually get to deal with the Pythagorean theorem. Now, the easiest way to explain a Pythagorean theorem is looking at a triangle. The Pythagorean theorem deals with only right-angled triangles. Now, in this case, I'm using the r, the x, and the y. I'll explain why later, but it makes matters simple. Now, what the Pythagoras theorem is saying that the sum of the square of this side and this side will equal the square of the hypotenuse. Now, I'll give a definition at the end, but actually you can actually pick it up just looking at the formula, that the sum of the squares, this is the sum of the squares of this side and this side, is equal to this one. Okay, now the last part that you need to know when you deal with the Pythagoras theorem is this diagram. It's called the Argand diagram or the Cartesian plane, which is another name. Now, from this diagram, you'll realize we can have 4 different triangles. So this would be your triangle, this would be your triangle, this would be your triangle, this would be your triangle. Now, they are actually not 4 different triangles, but they are positioned differently, as you would find in your examination or a test. Now, you'll notice that on our Cartesian plane, we have the y-axis and the x-axis. Now, in order to figure out, the first thing that you must do, in fact, when you're dealing with your Pythagoras theorem, is to label your triangle. So given a triangle from the Cartesian plane, you can easily tell this line is vertical, therefore this is my y, this line is horizontal, this is my x. Then the last part is actually would be the obvious part, because you would have the x, you'd have the y, then you are left with the r. So this would be your r. So looking at all this triangle, whichever way they've given you a triangle, the vertical line, the vertical side would represent the y, and the horizontal line would represent the x. Then the last part would be the y. It's actually the obvious part. You figure out the x, you figure out the y, then the last part is r. You figure out the x, you figure out the y, then the last part is r. Now, given this triangle over here, okay, given this triangle here, I'm gonna use okay, let me say 4 and 5 here. This is in meters. Okay, so I'm expected to calculate this side. This would be AB, the side of AB. So let this be my C. So I have my triangle ABC. I need to calculate the side of AB. Okay, so now our Pythagoras theorem, since I've explained, it says the sum of these two sides must equal to this side. Now the sum of these two sides, it would mean I would have my x squared plus y squared would equal to this side. Okay, now before we can go further substituting into the Pythagoras theorem, okay, now you notice I must label first. This side is a vertical line according to the Cartesian plane. Here is the vertical side, which means this would be my y. Then this one is the horizontal line according to the Cartesian plane there. Therefore, this would be my x. Then I go on into substituting into the formula. Now you look at the formula. It says x squared plus y squared equals to r squared according to the definition of Pythagoras. But you can also write this as r squared equals to y squared plus x squared. It actually doesn't matter. Okay, so this is according to the definition, but these two things actually mean the same thing. Okay. Okay, now in order to solve this triangle, let's stick to this formula. Okay, I have my r squared, which I have already labeled. I said you label your y, you label your x, then the last part is the obvious part. Obviously it will be the y. Now remember, don't forget to put in your squares, because this is Pythagoras theorem. It speaks about the squares of two sides, the sum of the squares of two sides equaling to one side. Okay, so in this case, where there's r there, as you see, there's no number, it's not given, so I continue writing r squared. Then I'm substitute. This process is called substituting. Now in this case, I look at my y. I have my y squared there. Where there is y, there is 4 there. So instead of putting y, I'm now going to put 4. So it's my 4 meters. It has a unit. Now, when I do this, I must put it in bracket. This represents the y. Then this is the squared, which is there from the formula. Okay, plus my x. Instead of x, I'm gonna put in 5. Therefore, this is my 5 meters. Then I'm gonna square it. Okay, therefore I've done my substitution. Now I have to solve the equation. Now therefore I have my r squared equals to, therefore now it's 4 meters squared and 5 meters squared. Now 4 squared would make this 4 squared, it's 16. Then m squared remains m squared, plus the 5 squared would be 25, and then the m squared would be m squared. Now don't forget to use the square on the number, also on the units when you solve. Now therefore I have my r squared equals to my 16 meters squared plus my 25 meters squared. Now when I add these together, I actually get a 41, I think. Okay, I got my 41, then it becomes 41 meters squared. Now we go back to our toolbox. You remember I said you need to know how to transpose and also how to deal with squares. Now in this case, we didn't have to transpose. Okay, when we get to this part, you realize that we didn't have to do any transposing, because the alphabets or the variables are on one side and the numbers are also on one side. But we now have to deal with squares. We go back to our toolbox there. You remember in the toolbox, I said you need to know how to transpose and also how to deal with squares. So in dealing with squares, remember that when you have an x squared equals to 25, it means that you're gonna put square roots on both sides in order to find your answer. So let's go back here. So you notice that as we stand, we have r squared equals to 41 meters squared. So it means I have to put square roots on both sides. Therefore, if I've put my square roots there, it means this square root would cancel the square. I'm left with the r. Then this side I have square root 41m squared, then you'd have to calculate the square root of that, and then remember the square root cancels the square. It means my unit will remain in meters. Okay, so you'd calculate this one and get the answer, but your unit must be in meters. Okay, in order to conclude this, I'm gonna show you 4 different examples. In this case, I have my A, my B, my C. This is my triangle, and I'm gonna have to calculate for AC, which is a line AC. And then in this other example, I'm gonna have my triangle, then I'll be calculating my AB. And then the third example, this would be my triangle, I'll be calculating for CB. And then the last example, I've been given everything. I only need to prove that AC squared equals to BC squared plus AB squared, which actually means I have to prove the Pythagorean theorem. Now let me show you something about the labeling of triangles. Now when a triangle is labeled like this, A, B, C, now this means that my lines, the line from A to B would be line A, B, and the line from A to C would be my A, C, and the line from C to B would be my line C, B. Now, since I said when you're dealing with Pythagoras theorem, it's always right angle triangles. Now you need to focus on labeling the triangle. Now in this case, this is the vertical line. It will represent my Y. Then this would be the horizontal line. It will represent my X. Then the last one is the obvious one, which is the R. Okay. Now looking at the Pythagoras theorem, R squared equals to X squared plus Y squared. Okay. You'd notice that I can actually substitute my lines there. Instead of writing R squared is equals to X squared plus Y squared, I can go there. I say my R, okay? My R is a line that starts from A to B, that line. So instead of the R here, I can write AB squared is equal to, instead of X, the line the X is the line that starts from C to B, which makes it a CB squared, then a plus. Instead of the Y is represented, that line that starts from A to C, and this becomes my AC squared. Now I know that's a bit confusing, but we'll deal with it when we solve these problems that I've put before you. Okay, now looking at the first problem, I've been given triangle ABC. Triangle ABC is a right angle triangle. I've been given this side and this side, and then now I've not been given this side, which represents the AC. Now in order to do this, I said the first thing that you need to remember, we need to label the triangle. This would be my vertical line, therefore it is represented by Y. This would be my horizontal line, which is represented by X. Then the last one, the obvious one, would be the R. Okay, so now I go ahead and write my Pythagoras theorem. It is R squared equals to X squared plus Y squared. Okay, now since they said calculate for AC, they didn't say calculate for R, for X, and for Y, but instead the Pythagoras theorem speaks about the R and the X and the Y. Okay, so in this case, what we need to do, we look at our R. Our R is a line that starts from A to C, which makes it the AC squared, right? Instead of writing R, we say AC squared. And we look at our X. Our X is the line that starts from C to B. So instead of writing the X there, I'm gonna put my CB squared plus. Instead of the Y there, my line is the y is the line that starts from A to B, okay? Therefore, this would be AB squared. Fine, okay? Having done that, now I need to substitute. So where there is r there's no number, it has not been given. Therefore, I continue writing AC squared. Now then I have the CB squared. The CB squared, the line that's from C to B, there's a number there which is 3 meters. Remember, we put it in brackets, therefore this becomes 3 meter squared. The line that starts from AB squared, so the AB squared, the line that starts from A to B would be my 4 meters. So it's 4 meters squared, okay? Now, this one is also actually easy because we don't have to deal with transposing, okay? Therefore, I have my AC squared this side, then my 3 meters squared. 3 squared will become 9, m squared will become m squared, plus your 4 squared becomes 16, and then your m squared becomes m squared, okay? Then you'd have your AC squared equals to, I'm gonna add the 2 now, so 9 plus 16, it means 25 meter squared. Now you remember, when we are here, we go back to the toolbox. This is our toolbox. This is how we deal with our square. Okay, so in order to deal with a square, we've seen that in the toolbox, we must put square roots on both sides. The square root cancels. The square, I'm left with AC, which is equal to the square root of 25 is 5. The square root of m squared. Remember, the square root cancels the squares. Then my last unit is meters. So the answer, they said calculate for AC. Then I've calculated my AC. My AC is equal to 5 meters. Okay, let us quickly look at the second example. Okay, I have my triangle ABC. I have the 5 meters, the 3 meters. Now, the first thing that we do, we label our triangle. Remember, the vertical line would mean this is the Y. The horizontal line would mean this is the X. And this would be the obvious one, which is the R. Okay, now we're expected to calculate for line AB. Okay, now remember our Pythagoras theorem is r squared equals to x squared plus y squared. Okay, now it's given in terms of r, x, and y, not in terms of a, b, and c. Now we check our r. Our r is the line that starts from A to C. Therefore, instead of writing r there, I'll be writing AC squared. Our x is a line that starts from B to C. Therefore, instead of x, I'm going to write BC squared. Our y is a line that starts from A to B. So I'm going to write AB instead of the y there. Therefore, this becomes my new formula. AC squared equals to BC squared plus AB squared. Okay? So now I'm going to have to substitute now. Where there is AC, I was given 5 meters. So here's my 5 meters. I'm substituting. Don't forget to put it in brackets, okay? Yeah, don't forget to put this one in brackets. Now we have my BC. Where there is BC, I was given 3 meters. Here's my 3 meters in brackets plus where there is AB. You notice where there is AB, I was given nothing. Therefore, I continue writing AB squared. Okay, now I need to calculate to work this out. Now my 5 meters, 5 squared is 25, meter squared is meter squared is equal to 3 squared will be 9, m squared will be m squared, and I'd have my AB squared. Now you notice this is where transposing comes in. Let's go back to the toolbox and check the toolbox. Okay, here's the toolbox. Remember the toolbox. When we're dealing with transposing, it means variables must be on one side and numbers must be on the other side. So in this case, I'll be moving this number to this side. Okay, back to our example. It means I'll be moving, these would be my variables, these are my numbers, right? So it means I'll be moving this one that side. So if I move that one this side, then I'll be left with ab squared here, right? Then this side I had 25 meters squared. Then this side this one comes to this side is 9 meters squared. Now remember, we are transposing, and this, since it has come to this side, it was positive. Now it becomes a negative. Okay, then we can solve now. My 25 minus 9, my 25 minus 9 will be 16 meters squared. Don't forget to put in your squares. And then this side I have ab squared. Now we come to we have squares. Remember how to deal with squares? We go to the tool. Okay, here's our toolbox. In order to deal with the squares, to remove the square, you must put in the square roots. Okay. Okay, now back to our example. We need to square both sides. So here's my squaring of both sides. Then I'll have my AB. The squared is gone. Is equal to, now the square root of 16 would be 4. The square root of m squared would be m. Therefore, my final answer would be AB equals to 4m. Okay, this is the third example. I've been given CB. Okay, the triangle ABC. I've been given the 4 meters here, the 5 meters here. There's a right angle triangle, and we are expected to calculate for CB. Now remember that the first thing we do, we label our triangle. This is the first line, the vertical line, it becomes the Y. This is the horizontal line, it becomes the X. This is the obvious one, which becomes the R. Okay, so my Pythagoras theorem is R squared equals to X squared plus Y squared. But now the line R is represented by AC, therefore it becomes AC squared. The line X is represented by BC, therefore it becomes BC squared. And the line Y is represented by AB, therefore it becomes AB squared. Okay, then we continue, we substitute now. When we substitute, where there is AC, I've been given 5 there, therefore it's 5 meters squared. Don't forget the brackets. The BC, where there is BC, I've not been given anything. I continue writing BC squared plus, okay, where there is the AB I've been given 4 meters there. It's 4 meters squared. Don't forget to put in the brackets. Okay, now then I can solve this one. 5 squared is 25 m squared, which is m squared. I have the BC plus the 4 squared, which is 16, the m squared, which is the m squared. Okay, now I have to transpose. Remember, alphabets must remain on one side. It means I'm gonna move this one this side. Okay, so I have 25 meters squared. This one comes this side, it's 16 meter squared is equal to BC squared. I'm left with BC squared now. So there's no operation sign now. If there's no operation, we look at this one. It was this side, it was positive. Then when it moves that side, it becomes a negative. Therefore, I have 25 minus 16, which is 9m squared, which is equal to BC squared. By now, we know how to remove the squares. We're going to put in square roots both sides. Then this becomes BC equals to the square root of 9 would be a 3. The square root of m squared would be m. Okay, that was the third one. Okay, now the last part of the example is that you've been given a triangle. It has everything. Normally they would give you a statement instead of a triangle. So when they give you a statement, you interpret the statement, you actually draw a triangle, then you put in whatever you've been given. Okay, now we have to prove that AC squared equals to BC squared plus AB squared. But remember that the first thing we do here, we substitute. Remember, we actually label. So this is my vertical line, represent the Y. This is my horizontal line, represent the X. And this is the obvious one, which is the R. Okay, so you come back here. In fact, labeling was not much of a big deal here, but it's fine. Let's look at this one. You say you prove this side. Now, in order to prove, it means your left hand side must equal to the right hand side. Okay? Yeah, I think you get it. So we know that the left hand side, this is the left hand side. The left hand side is AC squared, which is actually equal to my AC, which is 5 meters squared, which is actually equals to 25 meters squared. So now, in order to prove this, that the left hand side must equal the right hand side. Okay, so now I'm working out the right hand side. My right hand side is equal to BC squared plus AB squared, right? Now, my BC squared, my BC, the line BC is represented by 3 meters. Therefore, I have my 3 meters. I'm squared. Okay, and then we have the line AB. The line AB is represented by 4 meters. Then I have my 4 meters. Then I'm squaring. Okay, then I'm solving this. 3 squared would be 9, m squared would be m squared, plus 4 squared would actually be 16 m squared. Okay, then 9 plus 16 gives me 25 m squared. Now you'd look at this one, which is the right hand side, is equal to this one, which is the left hand side. So your final answer, therefore, AC squared, which is 25, is equal to BC squared plus AB squared, which is also equal to 25. Okay, thank you.